Okay, so I'm going to go over how to do the problems on the Algebra 1 Chapter 4 practice test. I'm going to do each problem with some explanation. If you need a deeper, more in-depth lesson, you need to watch the individual lessons that are linked on my website to each topic. So we're going to start with numbers 1, 2, 3, and 4. This is writing the equation in slope-intercept form, and this is when we're given the most of the information. So we're going to use y equals mx plus b to start, remembering that m is our slope and b is our y-intercept. So for number 1, if the slope is -3 and the y-intercept is -5, we're going to plug in -3 for m, and then we're going to plug in 5 for b. So y equals -3x plus 5. Number 2 is the same thing. Slope is -2/3. Y-intercept is -4, so we're going to plug in the -2/3 for m and the -4 for the b, and we get y equals -2/3 x minus 4. Now, one of the things we need to remember is what a y-intercept is. It's a part of the graph that crosses the y-axis. So it's any point here on our y-axis, and all of these points have the form 0, some number b. They are, this would be 0, -b. All of the points on the y-axis have an x value of 0. So if you're given a point that has 0 as the x value, that y value is your y-intercept. So that means there's something special about the second point that we're given here in number 3. 5, -2, and 0, -2. This point is our y-intercept. So we're given that. B will equal -2. But we have to find our slope. And our slope equation is y2 minus y1 divided by x2 minus x1. And that's given 2 points, x1, y1, and x2, y2. So my x1, y1, x2, y2. So I'm going to do m equals -2 minus -2. So it's always minus, so when there's a minus and negative, make sure you put that in parentheses so we can make sure there's an addition. And then 0 minus 5. This gives me plus -2 plus 2 is 0 divided by -5, and that equals 0. Okay, remember that 0 is on top. 0 over a number equals 0, and a number divided by 0 is undefined. Okay, we can't do a number divided by 0. But when 0 is on the top, it equals 0. So the slope is 0. That means for my equation, I can write y equals 0x minus 2, because we said b is -2. And we don't really write 0x because that just means the whole thing is 0. So really, y equals -2 is the final answer. Okay, number 4 is given, write a linear function f with the values f of 0 equals 4 and f of 5 equals 2. Now in function notation, that's just another way of writing an ordered pair. F of 0 equals 4, it means that it's the point 0, 4. For the function f, when x is 0, y is 4. And for the function f, when x is 5, the y is 2. So you can write it as an ordered pair, or you can just leave it and work with it that way in function notation. So the first thing we need to find is our slope. Notice, once again, that here I have a point that has an x value of 0, and that means this is our y-intercept. And so we have y equals mx plus 4, something times x plus 4. We need to find that slope. And we do that using this slope formula that we have over here again. y2, that's 2, minus y1, which is 4, divided by x2 minus x1. Now, it doesn't really matter what order you do you start with. You could start with y1, but you have to start with x1 in the denominator so that your sign is correct. So I have negative 2 divided by 5, and that's my slope. Y equals negative 2/5 x plus 4. And since it asked for a function, we really should be writing it as f of x equals 2/5 x plus 4. Here's a similar problem. Write an equation of the line and slope intercept form. So again, we're using y equals mx plus b. If I have a graph, you can see here, I have my y-axis, and this is where it crosses the y-axis, so that's my y-intercept. So my b equals negative 2. Then we need to find the slope, so it's rise over run, and it looks to me like it's up 2 over 1, up 2 over 1, up 2 over 1, so m is 2 over 1, which is 2. So to write that equation, it's y equals 2x minus 2. So the next formula we have is point slope form. Point slope form is y minus y1 equals m times x minus x1, where x1 comma y1 is any given point. And m is our slope again. So this one just wants us to write it in point slope form. And so when it says write the equation in point slope form, you can leave it in point slope form. You don't have to convert it to slope intercept. But there's only going to be one problem, so pay very close attention to the directions. So here I have 3 comma negative 9. So my x1 is 3. Let's color these a little bit. My x1 is 3. So that'll go in here. My y1 is negative 9. That's going to go here. And my slope is negative 4. So that's going to go in for m. So there's, oops, y1. Okay, so let's plug everything in. Y minus, I'm going to go with the yellow, negative 9 equals m negative 4 times x minus, with the green, 3. I hope the colors help you see what numbers are going where. And then since I get to keep it in slope intercept form, I get to just do y plus 9, because minus a negative makes it plus, equals negative 4 times x minus 3. And you'll see on the rest of them, when it asks for slope intercept form, we're going to distribute and then get y by itself. So here's another one. Here's where I have 2 points, and it doesn't show me enough of the graph to know where it crosses the y-axis. So I'm going to have to use the point slope form and find the slope. So let's look at this slope here. From this point, I'm going to go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and over 2. So that's negative 10 over 2. So m is negative 5. And I can use either point, okay? It doesn't matter which one I choose. So we're going to do y minus y1, which is 4. I'm going to use this point, equals m is negative 5, times x minus x1, which is positive 4. And so now I want it in slope intercept form, so I need to distribute and get y by itself. So y minus 4 equals negative 5x plus 20, because you have to multiply negative 5 times x and negative 5 times negative 4. And then add 4 to both sides. So y equals negative 5x plus 24. Now what if we're given 2 points without a graph? Again, we still need our slope and a point. So I have 2 points, but now I need to find the slope. Using my slope formula, y2 minus y1 over x2 minus x1 equals 4 minus negative 1, because this is my y2 minus y1, over x2, which is 6, minus 3. So minus and negative becomes plus, and I get 5 over 3. So we're going to plug it in, y minus, and I can use either point, so I'm going to choose the negative 1, comma 3, equals, m, which we said was 5/3, times x minus x1, which is 3. So I chose that point, and if I used the other point, I would get the same answer. So I get y plus 1 equals 5/3 x. And now we have to do 5/3 times 3. 5/3 times 3 over 1. The 3's cancel, and we get 5. Positive and a negative make negative 5. And then we're going to subtract 1. So y equals 5/3 x minus 6. And that's our final answer for that one. And again, number 9 is function notation, but really it's just giving us an ordered pair. 6 comma negative 3 and 3 comma 5. Let's find our slope. 5 minus negative 3 over 3 minus 6. That's y2 minus y1. y2 minus y1 over x2 minus x1. And that's 8 positive over negative 3. And we don't like negatives in the denominator, so m is just negative 8/3. And then I can use either point. I'm going to use the 6, negative 3. So y minus negative 3 equals m. M was the negative 8/3 times x minus x1, which is 6. Just make sure you're using the x and y from the same point. Then we're going to distribute. I get y plus 3 on this side equals negative 8/3 x. And 8/3 times 6 over 1. 3 goes into 6 twice. 2 times 8 is 16. They're both negative, so it becomes plus 16. Then we're going to subtract 3. And y equals, running out of space here, negative 8/3 x plus 13. And that's my final answer. Try not to get caught up in the fractions. If you did 8 over 3 times 6 over 1, you'd get positive 48 over 3, which is 16 as well. I like to cross cancel because it makes my multiplication smaller. Number 10. It says, no, I forgot the instructions, but it says, tell us which lines are parallel, if any. So, parallel lines have the same slope. So what I need to do is find the slope of each of these lines. So I'm going to take line A, 2y minus 3x equals 3, and I'm going to get y by itself. I'm going to do that by adding 3x. And 2y equals 3x plus 3, and then divide by 2, and y equals 3 halves x plus 3 halves, so the slope is 3 halves. The number in front of x is our slope. Then equation B, 2y equals 2x plus 4. So here we can just divide by 2 to get y by itself because the x is already on the other side. And we get y equals x plus 2. So your m is 1. Remember, there's always that imaginary 1 in front of the x if it doesn't have a number in front. And then equation C, 2y minus 2x equals 2. I'm going to add 2x to both sides. I get 2y equals 2x plus 2. Divide by 2. Divide everything by 2. Y equals x plus 1. Again, m equals 1. So our a and b, a has a slope of 3/2, m has a slope of 1, and c has a slope of 1. So b and c are parallel. B and C are parallel. And we can use the same information to do number 11, but we're looking at the graph, so that's kind of easy. We're just going to see what the slope is. We have down 2 over 2, negative 2 over 2, so m is negative 1. I'm sorry, negative 2 over positive 2. This middle line goes down 3 over 2, so m equals 3/2. And the last line is down 2 over 2, which is m equals 1. So if we labeled these A, B, and C, and I suggest you do that on the test, somehow label those so when you're telling me which ones are parallel, you can identify them. So we can say lines A and C are parallel. Let's see. This was the second page, the back page of the worksheet here. So we're going to start with 12, 13, and 14. Write the equation of a line that passes through the given point and is parallel. Well, what do we know about parallel lines? They have the same slope. So the slope of this is negative 3/2. So the slope of our new line is going to be negative 3/2. And we can use our point slope form. Y minus negative 2 equals m negative 3/2 times x minus 6. And then we get y plus 2. Distribute your 3/2 equals negative 3/2 x. Negative negative is going to make it plus. And 3/2 times 6 over 1. 2 goes into 6 3 times. 3 times 3 is 9. And then minus 2. Y equals negative 3/2 x plus 7. Now number 13 asks about perpendicular lines. Perpendicular lines are opposite sign and reciprocals. That means flip the fraction. So if you had an m of 5, you would make it 5 over 1, and the perpendicular slope, the symbol for perpendicular is an upside down t, would be negative 1/5. So here my slope is 3/4. So the perpendicular slope would be negative 4/3. So for number 13, we have a slope of negative 4/3 and a point negative 6, negative 4. And we're going to use our point slope form, y minus negative 4 equals m negative 4/3 times x minus negative 6. So that's y plus 4, negative negative makes positive, equals negative 4/3 x. Distribute, this becomes plus. So negative times a positive is negative, and 4/3 times 6 over 1. 3 goes into 6 twice, and 4 times 2 is 8. And then we can subtract 4, and y equals negative 4/3 x minus 12. So then we looked at some scatter plots. We looked at correlation. Is it positive, negative, or no correlation? Well, this graph, we read graphs from left to right. So if I'm looking from left to right, the general trend of this graph is going up. from left to right. So it has a positive correlation. And we want to say as x increases, y increases. Now, if the scatter plot looks like this, the overall trend is down from left to right. It has a negative slope. And as x increases, y decreases. And then no correlation looks like this. It's just a big cloud of points. It doesn't look like it has any relation. It's not going up or down. So this is no correlation. So number 15, we're analyzing a scatter plot. Use the scatter plot to answer the questions. What are the variables the scatter plot is comparing? Okay, that's what's the scatter plot about. Year and age. What is the scatter plot about in general? Age of American women at first marriage and the year. So would you say this graph has a positive, negative, or no correlation? Well, if I look at it, I see an overall increasing trend. Okay, so I'm going to say positive. And when I want to describe the relationship between the two variables, that's where I'm going to say as the year increases, age of first marriage increases. So here's our first question. What is the age of first marriage in 1975? So we go to our graph and we see that it's counting by five-year increments. So 1975 is here. And that looks like it's about in the middle between 20 and 22. So I'm going to say about 21 years old. And then it asked about what year had an average age of first marriage of 26. So let's go to 26 and then find the x value, the year. That's 2010. Next thing we looked at was the next three terms of an arithmetic sequence. An arithmetic sequence means we're adding or subtracting the same number each time. So here, that is called the common difference. We are subtracting 4. Subtract 4, subtract 4. So your common difference is negative 4. So what would the next three terms be? Well, negative 2 minus 4 is negative 6. Negative 6 minus 4 is negative 10. Negative 10 minus 4 is negative 14. So 6, negative 10, and negative 14 are the next three terms in the sequence. Now when we have, we want to write the equation for the nth term, we have this formula an. That means any term we want. An, any, equals a1. a1 is the first term, plus n minus 1, the number of term I want, times d, the common difference. So, and then it says find a10. That means find the 10th term. So here, what's my common difference between each of these? They're adding 3, adding 3, adding 3. So our d is 3. And our first term is negative 14. There's our first term. So we plug it into the equation. We leave an, that's like our y, equals a1, negative 14, plus n minus 1 times d, which we said was 3. And then to get a better equation, I can distribute my 3. So negative 14 plus 3n minus 3. And then I have like terms here, negative 14 and negative 3. So we get an equals negative 17 plus 3n. Now I could find any term I wanted. If I wanted to find the 100th term, I would plug in 100 for n. If I want to find the 10th term, I'm going to plug in 10 for n. So negative 17 plus 3 times 10 is negative 17 plus 30, which is 13. So remember that A1 is the first term. D is the common difference. These are the two things we plug into the equation. An is called the nth term. If n is 10, it's the 10th term. If n is 1,000, it's the 1,000th term. Last thing we looked at was piecewise functions. Evaluate the graph, or evaluating piecewise functions. So piecewise function is a function made up of several different equations, and each of them have a separate domain. For x minus 3, we use only x values that are less than or equal to negative 3. For negative 2, it only uses the x values from negative 3 to 5. And for 4x minus 5, it uses x values greater than 5. So I like to color code this. Let's color code this red, blue, and green. So the question is, if my x value is negative 3, which of these does it fall into? Is negative 3 greater than or equal to 5? No, so I wouldn't use this equation. Is negative 3 less than negative 3? No, there's no equal to on this, so it doesn't qualify here. Is negative 3 less than or equal to 3? Yes, so it qualifies here, which means I'm going to use the equation negative x plus 3. Negative x plus 3, which means negative 3 plus 3, which is 3 plus 3, which equals 6. Now let's look at g of 3. Where does that fall? Is 3 less than or equal to negative 3? No. Is 3 between negative 3 and 5? That's what this means, between negative 3 and 5. And the answer to that question is yes, it is between negative 3 and 5. So we would use negative 2. And what does that mean? That means no matter what x is, all those y values are negative 2. So when g of 3 is equal to just negative 2. Now what if it asked you for g of 7? G of 7 is greater than 5, so it qualifies for this equation. So we would plug it into 4x minus 5. So 4 times 7 minus 5. 4 times 7 is 28. 28 minus 5 is 23, and that's what it would be equal to. So there is one graphing problem you're going to have to do. So we're going to graph, and again, I like to color code it. I think it helps to see it. 2 pieces of our graph. And the graph is centered on the domain of 0. I highlighted that because both of these numbers are 0. So part of the graph is going to be less than 0. That's this equation. It says less than 0. And the other part's going to be greater than 0 over here. These are the x values, and then the y will graph. So this equation where it's less than 0, we're going to graph x minus 1. So I'm going to start at -1, and I go up 1 over 1. I'm going to draw the whole thing. And I don't want the whole thing though. I only want the stuff on this side of the x, because x less than 0. And I'm going to be even pickier. I want an open circle here. And there's a problem with having drawn my axis instead of using a picture. When I have an open circle here at -1, and I only want that part of the graph. And then the rest of the graph, I'm going to erase. Then for 5x starts at 0, 0. So this graph here is at -1, and 0, 0, my axis is getting all messed up here. I'm going to have a solid circle there. And it goes up 5 and over 1. And I only want the positive part of the graph. So I only want the positive x's, and I will have a closed circle because this is greater than or equal to. And so I'm going to erase this part of it. And then I have to now redraw because I just erased part of my axis. Open circle here, closed circle here. Okay, here is number 20. Number 20 shows us a table of table of data. We don't know what it's about, but we're looking at, consider the data in the table, which of the following choices correspond to the data. So the x values are 9, 11, 13, 15. So looking at the graphs, let's start with the graphs here. The two x values are the same. So the first point should be at 9 and 34. 9 on the x and 34 on the y. So it looks to me like this graph has the right x value because this has 34, 9. And that's not correct. So this is our first graph, so that's a good thing to show us. And if we're looking at the x values, 9, 11, 13, the x values are increasing. And you can only really look at that if it's in order. When the y values are going up 3, up 3, up 3, well, up 3, up 2, up 2, but they're increasing, right? Overall, they're increasing. So if the x's are increasing when the y's are increasing, this has a positive correlation. And then, so if it has a positive correlation, it's going to have a positive slope. So if we look at our two equations, I don't want you to do the work. Which one has the positive slope? Slope is positive and for B. So the answers are A, B, and D. If it was negative, then you would choose the equation C because it has a negative slope. And remember, the slope is in front of the x. And then number 21, write a piecewise function for the graph. So our piecewise functions, y equals, I'm going to write two equations and I'm going to write two domain restrictions. Looks to me like my domain starts here and goes greater than 0. Let's try writing x is greater than 0. Why did I use just greater than? Because this is an open circle. And then my graph, my other domain is less than 0. So x is less than or equal to 0 because this is a closed circle. So I know my first domain. We'll go from left to right. So it's the blue one first. X is less than or equal to 0. And then the next domain is x is greater than 0. Okay, so now we need to write the equation of the blue line, which is down here. This line has a b of -4. And we read a graph from left to right. So we're going to start here and go up 1, or up 2 over 2, up 2 over 2. So the slope is 2 over 2, which equals 1. So our blue equation is 1x minus 4, or if you want, you could just write x plus 4, or x minus 4. And then our red, this one here, starts at a positive 2, so b is 2, and it goes up 4, this is 2, 4, and over 2, so up 4 over 2 is your slope, which is 2. So if my slope is 2 and my b is 2, that's 2x plus 2 is my equation. And the last one, another piecewise function to graph that's extra credit. We have two different sets of domains, so I'm going to highlight -3. Okay, this is going to be my red graph. Between -3 and 2 is going to be my blue graph, and my green graph is going to be greater than 2. But I have these domain restrictions at -3, so there's 3 pieces to my graph here. -3, I'm going to have this equation. This equation will be over here. And then I have -2, +2. So now we have the area between the two, and that'll be y equals 2. And then we have the area to the left. So we have 3 pieces of the graph for 3 equations. And the y equals -3. This graph goes on that side. So we're just going to graph it and erase what we don't want. So we start at -1. And my slope is -1/2, so I'm going to go down 1 and over 2. And I'm going to go up 1 and back 2. So I can get a nice straight line. And I'm only interested in x values that are less than -3. So I'm going to start my graph here. And I'm going to erase the rest of it, because I don't need that part. And it's less than or equal to, so I'm going to have a solid circle right there. Then my next y equals 2 is a horizontal line where all the y values are 2. And I only want it between -3, open circle, and 2, open circle. So I'm going to erase the sides. And then lastly, 1/2 x starts at 0, 0, goes up 1 over 2, up 1 over 2. And it's an open circle on the line. And I only want things to the right of that line, and so I'll erase the rest. And then whether you erase your dashed lines or not is okay. There you go. I hope this helps you study for the test.